name is Aviv Zohari. I'll introduce myself more in a second. Thank you all for coming. I'm really excited to be here. It's my first time speaking on this stage, so it's going to be a lot of fun. I like this section here. Right side, you still have a lot to try and do. Thank you. All right, so we're going to be talking about one of my personal favorite subjects, which might sound a bit boring, but it really is, which is cross-availability zone traffic and how it is killing your cloud bill. By raise of hand, are you here because this happened to you? All right. So even if it hasn't happened yet, it might happen in the future, so keep that in mind. All right, so about myself. I'm a field CTO at Groundcover, which is the company responsible for this awesome swag. I really like observability. I've been doing it for about 5 years now, and I keep finding new things and new stuff that we can do. Awesome technologies, a lot of players in the market. It's very interesting to see what everyone is doing. I just became a dad a few months ago. Thank you. So please excuse me if I happen to fall asleep during the talk. It's one of those things. And just to get you kind of hyped on what we're going to be talking about, if you look up the term cross-availability price or cost or something like that on Google, yes, if you still use Google, then you're going to end up with a blog post by this lovely lady who essentially tells the story of a team that went through the adventure of finding out why they're paying so much for cross-AZ traffic. They ended up actually, let me just read the quote. Once we fixed the issue, the daily cross-AZ data transfer dropped by 95%, which cut our AWS daily cost by 23%. Crazy. It is crazy. And like you've just mentioned, this happened to some of you as well. So I don't know what tools they've used exactly, but they're not sure they used what I'm going to show you. And if they did, they would have done this much faster. So what are we going to be talking about? Resilience. Why is it not cheap? Why do we have resilience? How the cloud vendors tell you should be investigating this problem, but why you shouldn't be doing that way. eBPF and Kubernetes, 2 technologies that work amazingly together. And we'll see how that all kind of comes together to solve this specific problem. So we're going to start with a quote by Amazon CTO that essentially is a very, very smart engineer who tells us that everything fails all the time. And you should plan for it, because you can't do happy flow. Happy flow does not happen in real life. It sometimes happens, right? But you still need to be able to come back when things crash, right? And Amazon, well, a month and a half ago, I guess everyone here remembers this wonderful day when an entire region essentially went down in AWS. So yes, they also suffered the same problem, but I mean, like it or not, took them some time. They came back up, right? They probably learned a few things from it, but they have to plan for it. And one of the best ways you can do it, or one of the, well, not the best, but common ways you can do it are availability zones, right? So everyone here knows them. Essentially, you separate them on geography, logically, so nothing depends on, one zone does not depend on the other. And it should help you when one zone crashes, right? By the way, again, in US East 1 case, the entire region fell down, so it doesn't help you with everything, but it might help you with a lot of problems. So you can do stuff like have your compute on different zones, right? It's very common. You run on different zones, make sure that you always have your workloads running. Maybe you have your databases spread around different zones. So again, if one availability zone dies, you still get your data. Kafka is another great example, right? Message queues, you want to make sure that messages are always delivered. You get the point, and I'm sure everyone in the room already, this is redundant for you, right? But just to emphasize, this makes a lot of sense. So you want to spread your risks. You don't want to have everything depending on one place in the world that might get flooded, right? Makes sense. But it's not cheap. And specifically with AWS, it costs a lot of money just to have this traffic between applications. And let us all remember, most of us run microservices nowadays, so there's a lot of applications, a lot of traffic. If we take a look at the right side of the picture, on the red arrow, we can see the baseline, which is essentially you're paying 1 cent per gigabyte on the way in and on the way out on every single byte of traffic going between the zones. Also note that you're paying it on both ends, right? So if you're both the client and the server, then you're essentially paying 2 cents per gigabyte. And of course, it depends on your architecture, but this is very common. putting some numbers on it, let's say that you have 10 terabytes a day in, 5 terabytes out. So that's 15 terabytes total that you're paying on each direction. So that's going to end up being $300 a day or $9,000 a month just to send bytes between servers, right? It's crazy. Now, for those of you who might say, well, 15 terabytes, that's a lot of data. I mean, who has that much data? Well, obviously, in real life, there's a lot more going on all the time. And again, because of microservices architecture, because of the way that we've multiplied essentially the number of hops between services, these numbers are very common. Note that I'm constantly talking about AWS. So with GCP, Azure, and the others, it's not that much of a problem right now. But who knows? Which is why you kind of need to be on the lookout. It doesn't matter what you're using. All right, so what do we do? Let's say that, I say by raise of hand, I already asked before, how many of you have opened Cost Explorer and saw this inter-AZ bill spiking and said, what is happening here? All right, quite a few. And again, if you haven't yet, don't just wait. So the problem is you open the Cost Explorer, and essentially they tell you you've been billed $9,000 this month, but for what? Some cross-AZ communication over something. So AWS says, what's the problem? You can use VPC flow logs. Essentially track down every communication, every byte flowing between your VPCs. You can know if it's crossing availability zones. We'll tell you that. And then that's it. I mean, you can track down the problem. What's the issue, right? You can use Athena essentially to query this over CloudWatch. And yeah, problem solved. I mean, why is anyone complaining? Well, first of all, a typical setup might look something like this, which I'm not going to explain. It doesn't really matter. It looks complicated because it is. There's so many pieces here that you have to turn on in different places. You have to ship the logs. You have to store the logs. You have to query the logs. Someone has to process the logs. It's a whole thing that Amazon doesn't. I mean, they sort of help you do it. It's not exactly easy. But the actual problems are, there's two problems. The first one is VPC flow logs give you IP addresses, which is fine, but I don't know my IPs necessarily. Maybe it's some EC2 machine, which I do know the IP, but it's running dozens of applications. So which application did this traffic? Maybe it's Kubernetes. It's so much worse than Kubernetes, right? Because IPs keep changing between pods. 1 minute this pod has this IP, another minute another pod has this IP. And if I'm looking back like a month of data, it's useless, essentially, right? The other problem is it costs a lot of money to just turn on VPC flow logs. Yeah, I can see the nods here. Because you have to store everything. It's essentially debug mode, right? You're trying to track down every single connection made between every single IP in the system. It has to be like a very, very, very high volume. And it can actually end up costing you kind of like the cross-AZ communication itself. So you might say, fine, I'll turn it on, I'll solve the problem, then I'll turn it off. But I mean, come on, we all know that doesn't really work. All right, stopping for a second, just to breathe on this terrible problem. What are we actually trying to do? So we're trying to know, first of all, who is sending cross-availability, right? So we saw this bill. It says nothing about the identities of the services or the clients and the servers. So that's one thing. Second thing is, what is being sent? Is it just API calls? Is it queries? I don't know. What is it? Then we probably want to understand what is the behavior over time. Is this just something that happened once, or is it happening all the time, every single day? And then lastly, did we mean to do it? Because we started from resiliency, and maybe everything is fine. I'm going to stop for a second and say, sometimes you just have to pay the price to have more resilient infrastructure. That's fine. But a lot of times you did it by accident, or maybe you weren't aware of how much it's going to cost you. So we're going to try and build this differently. We're going to try and build this bottom up. So let's start by emphasizing that we want services, we want workloads, we want something that we can work with, that we can ask, is this what we intended? Not IPs. And for a lot of cases, and I'm going to be focusing a lot on Kubernetes and VMs and nodes, this can still be applied on other use cases, but it is the one that's, I think, most powerful, especially because of the way ephemeral works in Kubernetes. So our services are going to be scheduled on nodes, on hosts. And we want a way to kind of monitor the traffic from those nodes or those hosts and translate the IPs that we see to workloads real time. Because like I've mentioned before, if you try to do this in hindsight, it's just not going to work. You have to do this as you record the traffic. Any guess on how we could do it? Did someone read the abstract? No, I'm just joking. But eBPF. So this is not an intro to eBPF, but what we need to know is that it's a technology in the Linux kernel that lets us tap in the kernel in a way that's safe, so we don't need to worry about deploying it in production, but it's still very powerful. It lets you tap into system calls, into file operations, and specifically into the networking stack, right? So you can write code that tracks every network call, send, receive made on the host and record it. You don't need Amazon for that. You can do it with eBPF code on your machine in 2 minutes. Awesome. So let's say that we've done this. We've pulled all of our courage. We wrote eBPF code, and now we're tracking all the connections on each node and virtual machine. So if you're looking at Kubernetes, for example, you would have your pods communicating with one another. We would have our daemon set, this agent that's running, that it loads the eBPF code into each machine. And we're able to tap into the network layer and track down the communication, the IPs, the traffic, the bytes, all of that, we have it. But we just said we don't want IPs, and eBPF doesn't know it's running on Kubernetes by itself or on whatever. So we need more context, and how are we going to do that? So, for example, we could use the getPods API from the API server. Same thing that's happening when you're using kubectl getPods, right? You get the list of pods that are currently running with their IPs, with everything you want to know about the service. So you can map this live. So you can say, I see communications between IP A and IP B. These are actually those pods. We'll see that in a second. Now, we're not done yet because pods aren't on AZs. Nodes are. Right? Pods are just logical. So we need to figure out the nodes. Well, no problem. We can do the same thing. We can get the nodes, and then we can go from pod to the node that's running it to the AZ that the node belongs to. Right? Awesome. So if we put all of this together, we started from eBPF. We've tapped into the system, into the network calls, and we've tracked down 2 IPs that are communicating, right? We don't know anything beyond that just yet. We then translate that into the services, right? So these are pods. These are logical services that we can track down to actual teams and actual people, right? Then we've moved to nodes, which is just kind of a step in the middle that will let us know that this might be cross-AZ. Now, not everything is cross-AZ, right? By the way, cross-AZ, I like that kind of in the, never mind. Not every communication is cross-AZ, but now we can take every bit of traffic and determine, is this cross-AZ, is this not cross-AZ? And if it is cross-AZ, then now we know the exact pods that did this communication. We know this live. We don't have to kind of pray we can do this in hindsight. All right, so we did all of this hard work. We've written eBPF code, and we've connected to the Kubernetes API server, and all for what? Well, to be honest, it is pretty awesome. So we can start visualizing and tracking what's going on in our environments. So for example, here we have a query that's taking a look at all of the traffic that is cross-AZ in the system, but the terms that we're using here are not IPs, they're workload names, they're service names, clients and servers that we know. And we can see the behavior over time. That's also something we wanted to be able to see. And we could track down and say, well, for example, here we have this pair of workloads. We have this cube state metrics and Prometheus, which are cross-AZ. Should they be cross-AZ? I mean, does it make sense for them to be cross-AZ? Maybe, maybe not. But now we can start working on this. We know what's the cause of the cross-AZ communications. And it actually gets even better. We can do stuff like finding out which namespaces have the highest number of cross-AZ traffic. And we can use other eBPF features to actually dive down into the actual API call. And this is a whole other level of awesomeness, right? Because now we can say, not only do I know they're communicating, I can see exactly what's happening here. Why is this /shop/card API cross-AZ? Again, does this make sense? And I have to always stop and say, maybe it does. Maybe everything is just fine. But now you know. So let's summarize with a flowchart. First of all, if you're not built for cross-AZ, maybe everything is fine. right? When you open the Cost Explorer, you have a bunch of other problems, you're fine. Maybe it's not a big bill, right? And again, of course you want to solve everything, but you have to start with the things that matter. That's fine. Maybe it's fine because you did expect RustAZ. This is your architecture. Still fine. But maybe it's not fine. Maybe you've just opened one day and you have no idea what's happening, and you want to solve it, and then it's eBPF for you. I do have to, by the way, say that even if it's not a problem today, the nice thing about this method is that unlike VPC flow logs, which you might turn on when you have to, right? You have a problem, you turn it on, you wait a week, you try to figure it out. This is a very lightweight method that essentially you can capture it all the time and even alert on it, right? Like just set an alert that if there's too much cross-AZ traffic, let me know after an hour, not at the end of the month. All right, so what do we do from here? Well, there's multiple tools you can try. Ground cover is one of those, but it's not the only one. There's multiple tools that went this direction of tracking communications with eBPF that you can try out, you can deploy, you can see what's happening. That's awesome. I also suggest reading on more stuff with eBPF. eBPF has a lot of cool use cases. Not all of them have to be full-blown out platforms, right? Sometimes you just run a tool, it lets you see something, and you're done with it. That's awesome. And I also have to say that Kubernetes actually went and added some things that relate to it. So in 1.34, there's actually zone-aware topology that lets you define services that prefer to stay in the same zone. Something that wasn't possible until just recently. Essentially, finally, someone admitting there's a problem, and you want to solve it from the root cause, right? I want my services to talk to services in the same zone. It's not that hard, right? So yeah, there's a lot to try out, to play around with. Any of those tools, any eBPF tools you deploy, you're going to find out crazy stuff you didn't know before. I can guarantee you that. And that's it. Thank you so much.